Hello everybody and welcome to my video on exploratory data analysis and box plots. We have talked about in a previous video on measures of centrality and spread, and now we would like to go into this idea of exploratory data analysis, which is another way of taking a look at a data set. So I'd like to start off by talking about measures, breaking the data apart in measures of position or measures of location. So the first one we'd like to take a look at is called percentiles. Now, percentiles will break the data up into parts of 100. So in this case, here we have, for example, this value right here as the 30th percentile. And what this means is that 30% of the data lies to the left. So the 60th percentile means that 60% of the data lies to the left. Now, given a data set, notice that the data set is sorted from smallest to largest. All right, so in this ranked order data set, there is a way to compute what the 50th percentile, what say the 43rd percentile of a data set is. And we're not going to have you do that, but there are ways of computing that. So just recall that percentiles always means how many pieces of data lies to the left. Now, if we want to talk about what percent of data lies to the right, we talk about the upper percentile. So for example, the upper 20th percentile means that 20% of the data lies to the right. And notice that because 20% lies to the right, that means that 80% must be lying to the left. So as far as the value is concerned, the upper 20th percentile is exactly the same as the lower 80th percentile or the 80th percentile. Okay, so the next way of breaking up a data set is in parts of 10, and we call these deciles. So again, you don't have to worry about computing these deciles, but if you ever hear or see this, which I have rarely, personally in my experience, seen deciles, but I have read about deciles in education literature before. These deciles, this is the third decile, and the third decile is exactly the same as the 30th percentile. The sixth decile is exactly the same as the 60th percentile. So when you talk about the seventh decile, that means that 70% of the data lies to the left. So there is a relationship between deciles and percentiles. And the last one is something that we will use, and this is quartiles. And this is a way of breaking a data set up into parts of fours. So notice here we have the first quartile in which 25% of the data lies to the left. The second quartile in which 50% of the data lies to the left. And notice that the second quartile is also the median. The third quartile is where 75% of the data lies to the left. All right, so notice that when we have our first, second, and third quartile, we have our regions broken apart into this first quartile grouping or first quartile region, second quartile grouping, third quartile grouping, and finally we have this fourth quartile grouping, and we'll get into that in a little bit. So let's take a look and see how we can compute these quartiles and what they do for us. So this is a data set that I had from a class that I taught a few years back. And this data set is the overall class average. So this is what the A, B's, and C's are based off of. And these numbers actually are percentages. So when I take the data and sort the data, just like we did to compute the median, you take a data set and you sort them. So to find the quartiles, Q1, Q2, and Q3, the first thing we'll do is find the median. All right. So the median of this one is discussed in another video. So I won't go into how I came up with 86, but there are 31 pieces of data. And so you go 31 plus 1, which is 32 divided by 2. And notice that we go to the 16th location, which gives us this value of 86. So that means that 15 pieces of data lie to the left and 15 pieces of data lies to the right. So to get the first quartile, hopefully it would make sense that we take the median of this lower 15 pieces of data. So I'm going to take these lower 15 pieces of data, and I'll find the median, and notice that that comes out to 72. And then to get the third quartile, which is the median of the right half of the data, the right half from 86, and I compute the median here, notice that it gives me a value of 95, right? So that is our Q1 is 72, Q2 is 86, Q3 is 95, and then notice that we have 4 quarters. So here's quarter region 1, quarter grouping or region 2, quarter grouping or region number 3, and quarter grouping or region number 4. So now that we have that, the next thing to do is to come up with an equivalent measure of dispersion, and that is what we call the IQR, or the interquartile region. So this is defined as Q3 minus Q1. So Q3 is 95, subtract 72, that gives me a value of 23, or 23 percentage points, since these are in percentages, which tells me that the variability, or the range of the middle 50% of the data is 23 percentage points. Okay? So another measure that we talk about is a measure called the upper and lower fence. And the upper and lower fence is going to help us out. One of the applications is to identify potential outliers. Remember, an outlier is a data value that lies far away from the bulk of the data. So for example, if we were to take a look at you guys, the whole class, and take a look at your average annual salary, but we also had Bill Gates and Jeff Bezos in our class, I think we can take a look at their average annual salary and see that it is probably way more than what we all make. Or at least for me, it's true. I don't know. Maybe you are different, and maybe you can identify with those guys and their salary. I don't know. So the lower fence is defined as Q1 minus 1.5 times the IQR. So the idea is that if I go to Q1 and then I extend below Q1, 1.5 IQRs, anything below that fence line is considered a potential outlier. The upper fence line is Q3, and then I go 1.5 standard deviation, or 1.5 IQRs above Q3. Anything above that is considered a potential outlier. The second thing we'll use the fence line for is when we go to create our box plot, and the fence line will help us to identify what is referred to as adjacent values, and we will use those adjacent values to extend our whiskers from the box plot. But let's continue on with identifying outliers. So the lower fence is 72 minus 1.5 times 23, which comes out to be 37.5. And the upper fence is 95 plus 1.5 times the IQR. So this comes out to be 129.5. So as I take a look at my bulk of data and consider these fence lines, we can kind of throw these values in right here, and notice that nothing lies above 129.5 because the maximum value here in this case is 100. So there's nothing to the right that I have to concern myself about. But as I come over here to the left, notice over here from 37.5, notice here that these two values kind of pop up. So as an instructor, and this being a class average, this puts up a red flag for me, and it would help me to be able to identify who these people are and why these people have such a low percentage, and I can use that and kind of follow up with. All right, so this is our data set, and this is how we come up with the quartiles and the fence lines, and this is how we come up with identifying potential outliers. Throughout our term, we'll talk about a couple of others. One you've probably read is called using z-scores, and anything above 3 standard deviations is considered a potential outlier, and anything less than -3 standard deviations, or a z-score less than -3, is also considered an outlier. Okay, so that is the my summary for introducing right now this part of the exploratory data analysis. To continue on in exploratory data analysis, we have this thing called the five-numbered summary. And the five-numbered summary is a continuation of the quartiles. So let's just note that the five-numbered summary is defined to be, well, there's our friends Q1, Q2, and Q3, along with the minimum to the left and the maximum to the right. So if I put all this together, coming back to our class average, notice that I have a minimum of 13. I have a Q1 of 72, Q2 of 86, and so forth. All right, so one of the things I can easily see is notice that I have these regions over here. This right here is my first quartile region. Here is my second quartile region. And then from the median all the way Q3 is my third quartile region or grouping. And then this one here would be the fourth quartile grouping. And one of the things I might be interested in is to compute the spread or the range of these quartile regions to see what kind of variability is going on in these quartile regions. So let's just observe here that if I use the raw data set, notice that I have this 72 minus 13, which is 59. I have my Q2 minus Q1, which is 14, and Q3 minus Q1 is 9, and then we have our maximum minus our Q3, which is 5. So our Q1 minus the minimum, I guess I should say, gives us 59. But notice earlier, and again, I'm going to bring this up coming up here in our next phase in box plots. Let's just observe that we had right in here at 37.5 our fence line. And since we have now identified these as potential outliers, I may not want to consider them part of the quartile region 1 because they have been identified as outliers. So rather quartile 1, and again we'll see this when we get to the box plots, we might want to just consider from 63 this adjacent value of 63 since it's adjacent or next to the fence line, okay, up here to 72, which now gives me a new updated quartile region spread or range, if you will, of 9. So this quartile region then going from 63 to 72, this quartile range then would be 9. My quartile range for part 2 still stays the same. It's 14. And then the quartile range for the third part still stays the same at 9. And then this one here from 95 to 100 will still stay at 5. So what this tells me then is that the largest amount of spread in my data set occurs right here on this second quartile region from 72 to 86. And my least amount occurs right here from 95 to 100. And this is going to be brought out, and we'll actually visually see this a little bit better when we get to box plots. All right, so the five-numbered summary is something that we can compute, and when we compute those, it breaks the data into our fourths, and then we can take a look at each fourth and take a look at how their spread appears to be. All right, our final component down here is box plots, or a plot also known as a box and whiskers plot. So again, notice that this box plot, as you've read, is based off of our five-numbered summary. So notice that the box component is based upon Q1, and Q3 forms the perimeter of the box. And then we go ahead and toss in the median. And sometimes some people like to throw in the mean. It is not necessary. And for the most part, you don't see this, but it kind of shows a little bit of the difference when you have a skewed distribution. It will kind of help us out, and maybe there is a little bit of separation here between the two graphs, because as you previously learned, that when a data set is bell-shaped, the mean, median, and mode are all the same. Now, to extend out the whisker, which I'll be getting to here in a little bit, is that we extend from, in this case, Q3 all the way out to the upper adjacent value, and here we extend from Q1 out to that adjacent value. This is, in this case, that adjacent value appears to be the minimum value, and again, we'll see that in a little bit, and outliers are denoted with stars. So let's come back and take a look and just recall that it's easiest to start, to get a starting point if you have to do these by hand. Now remember, everything I've talked about in this video thus far, you are not expected to do this by hand. All right, I have a video that shows how to do this, and it's just creating a box plot. And once you have it, then it's interpreting what you're looking at. So that is the important part. It's not so much you taking a pencil and paper and creating a box plot, but it's using technology, create the box plot, and now tell us what's going on inside that box plot. So let's talk about manually creating it so you know what the technology is doing for you. So again, I'll start off with Q1. So notice that Q1 is 72. So to start off with my box, I got my little box segment right here. And then I'll go ahead and toss in Q3, which is 95. And then I'll go ahead and throw in the median, which is 86. And now I'll just go ahead and complete off my box. Okay, so now the question is, where do the whiskers go? How far down do I extend the whiskers? Now, in some cases, they will go to 13, and in some cases, they will go to 100, but we've got a special way of doing this because we want to make sure that we highlight any outliers. So to do that, let's just note that when we extend, kind of think about this starting here at the median and walking towards the fence. Notice that before we jump the fence, that the last data value that we hit is 63. So this 63 forms our lower adjacent value. And it's that adjacent value that we will extend the whisker to. So notice that this is what we do is we extend down here to 63. That is our adjacent value. And coming back over here, starting at the median, and if I walk to the upper, notice that my adjacent value, my last value before I hit the fence, is 100, and my fence line is all the way out here to 129.5. So the maximum value also serves as the adjacent value. All right, so let me repeat that. The maximum also serves as the adjacent value. So we'll just go ahead and pop that in there, and this is our box and whiskers plot. And notice before that when I was talking about that variability, maybe we should only just go down here, and notice it kind of brings that out. So this was a value of 9, which was the same as this one here was a value of 9. We can easily see that that second quartile region had a value of 14 for its spread, and we can see that this is bigger than this component and this component right here. And notice that this one here was the smallest, that went from 95 up to 100. So everything is hopefully visually making a little more sense. And with our box and whiskers plot, we can easily see that this region has the largest amount of variability, and this region, the fourth quartile region, has the smallest amount. So now we have to deal with our outliers, and notice that we saw with our picture that the outliers are formed by these stars. Okay, so there is our 13 and our 24. So again, when you go to compute these or construct these, it's not so much that you construct them and do them paper and pencil by hand. Let the technology do the work for you. Let your brain do the interpretation for you. So tell me what you're looking at, okay? So one of the things with graphing numerical data is trying to get an idea about the shape of the distribution, because it is important to know the shape of the distribution because it will tell us which set of summary statistics that we will use. Do we use the mean and the standard deviation, or is it better to use the median and the IQR as a measure of location and as a measure of spread? So notice here that this box is a little bit offset between its whiskers. Notice that this one here on a skewed right distribution has an elongated whisker to the right, whereas the skewed left, this one is shifted over to the right, but notice that this one is elongated. When the distribution is symmetric, notice that the box pretty much sits right in the middle of the whiskers. All right, so I just want to point out that this is an art graph reading is an art, to be honest with you, but these things better be elongated. That's what I'm also trying to say. So if these things are not elongated, then it's probably better to say, better to err to the side of approximately bell-shaped. Okay. So coming back to our box and whiskers plot, notice that even though this is longer than this, notice it's not that much longer. All right. Now, if this whisker to the left was extended down to here, then yeah, I would probably then come back and say this distribution is skewed left. But I'm going to ignore these two outlier points for right now. I really don't need to worry about those things when I'm identifying the shape. I have 29 pieces of data inside this box to help me identify the shape of this distribution. So personally, I probably would come back and say that this box plot might be slightly skewed left. But would you be incorrect if you said it was approximately normal? And this is where we get a little bit in that gray zone. So don't be surprised. There's no absolutes unless something is absolutely out there. So again, if this whisker was extended down to here, really elongated, then yeah, I would definitely say skewed left. But I've got some slightness going on here. So if I had to pick one or the other, which is what you have to do, you have to pick one and, kind of hope for the most. It's not like you're going to fail anything, but I would probably go with slightly skewed left with this distribution. All right, so that concludes our video, and I sure hope that this helped you to better understand the exploratory data analysis. That is what the quartiles are, what the 5-number summary is, how to use the lower and upper fence to identify potential outliers, how the upper and lower fence is used to construct the whiskers on a box plot, how to create a box plot, the 5-numbered summary, compute the quartile regions, the ranges, to identify which range has maximum or minimum amounts of variability, and what a box plot is, and how to interpret and identify shape. All right, I think I've talked enough, so I'm going to bid you adieu.